Heyo. Welcome back, guys. We're going to do Lab 17. We're going to look at Lab 17 in C++, which is on algorithms. So I'm going to start by opening just a console application for now. And I don't know, I'll give it a name, something. And so there it is there. The two libraries we want to include are vector. Oopsie. Because we're going to take our big lists of numbers and we're going to do stuff on them. And then algorithms as well. And there we go. Okay, so let's make a vector of, I don't know, 100 random numbers or something. So I guess I'll need the other ones that do random numbers, which are the standard library. There's other ways to do random numbers now in C++. And they're kind of confusing, so this is the old school way to do it. It's what you would use, the way to do it in the language C. And that works well enough for us. So I'll type srand, I'll type the word time, and I'll put 0 there. And that gives us a little bit of randomness. And I'll make a vector that's going to hold some integers. I'll call it my lister. And I'll put 1,000 things in there. So I will say, I'll make a for loop that starts at 0 and goes to 9999, which is 1,000, right? And then I'll hit plus plus, and my vector is called lister, and right now it's empty, but if I push back on it, oopsie, just a random number like this, rand %, I'll just say random. It doesn't have to be between anything. Now notice I don't have curly brackets here. When you make a for loop in C++, if you just write one line after it, it'll put that in the for loop and you don't need to make brackets. It's a little bit of a cleaner way to make code if you want to do it that way. And let's run it. I'm just going to put a stop sign there and run it and see how it did. And there's my vector of length 1,000, and it's just filled with random numbers, as you can see. My debugger doesn't want to print them all out. Okay, but I could print them out if I wanted to. I could actually put a curly bracket here. Oops, and paste that, and then see out lister.back, which is the one I just added, right? And that'll put out my list of numbers. Okay, so that's good. Now we have this big list of numbers. Suppose we want to sort them. Well, there's lots of different ways to sort a list of numbers in computer programming. And in certain computer programming classes, it's a good thing to learn how to actually sort something. And we're not going to do that right now just because everything's online here. So I'm just going to show you like a really efficient way to sort this thing. And it's a command that we're going to use from this algorithm library. So if you go to c++.com, which is like a reference site for C++ commands, just hit reference. You can look at all the different libraries and all the functions that are in them. So if you go to containers, there's our vector. Where's our vector? Right there, and you can see all the stuff you can do with vectors. I don't know why that's, oh yeah, you click vector and then you can see all the different things you can do, and it tells you what each does, and it usually gives you an example how to use it. Sometimes it's a little overcomplicated. It's not as good as like a tutorial website, but it's going to be useful for us. So there's algorithm there, and you can see all the different things we can do. There's like a find algorithm. It says find a value in the range. There's a find if not. Count the appearances of a value in the range. There's some copy stuff. There's replace stuff. That's not super important to us. Here's some sorting stuff. Let's click on sort and see what it does. Sorts the elements in the range first to last in ascending order. So if you look at a little example there, the examples are pretty terrible, but you basically have to call the command sort. Okay, let's do that. We'll write sort, and then in brackets, see how it says array iter? It's an iterator in C++ is basically just the memory address of the first element that you want in a list. So I'm going to say dot begin. We've used dot end before as well. And lister, or I've talked about that a little bit in the last video. And lister dot end is, and notice when I type dot end, see how it says iterator there, constant iterator. Okay, so basically when I call sort, I need to tell it where the memory address is of my first element and where the memory address of my last element is in the memory, and then the thing will go through the memory and sort it. So let's maybe let's pause it right before we sort it in the debug and check it out. Okay, so printed them all out. Do I have my little watch variable here? Okay, so there's all the random numbers it came up with, 1,000 of them. It's not going to write them all. Looks like it maxes out at 200. I'll go to my next line after the sort, and you can see that it has sorted them from smallest to biggest. Okay, and so we took advantage of the algorithm library, didn't make our own set of instructions to sort it, which is a fun thing to know how to do, but we're not there yet. If you want to sort a list of things, try it on your own. It's actually not that hard, but this is a quick way to do it for us, and an efficient way, because I'm assuming that if this sort function is in a C++ library that's shipped with C++, it's probably pretty efficient at doing so. So there's the sort one. Here's another cool one that we can use. Let's say we make a vector but without random numbers, like I'll call it another vector of ints, right? And maybe I'll call it cards. I think this is an example in the book, or in the lab. So I want to make card values between 1 and 10, right? So I'll say I is less than or equal to 10, and I plus plus, because I'm making a blackjack game or something like that, and the ace is worth 1, and the queens, kings, jacks, and 10s are worth 10, and the face value, spot cards are worth their face value. Well, what I'll do is I'll say cards dot push back, right? And then I could say I or something like that. And maybe I could put this all in a loop that runs 4 times so that I could kind of get 4 suits of cards. And this isn't super accurate just because there's 52 cards in a deck and I'm only adding 40, but hopefully you can get the gist of it here. But this is my kind of organized way of adding 40 cards to the deck. The problem is it's just going to put them in order like 1 through 10, and then 1 through 10, and 1 through 10. And I'll have 40 cards in my deck. Let's see how this works. I'm going to pause it here with a debug stop. Okay. And if I look at my watches, there's my lister, which I don't care about right now, and there's my deck of cards that has 40 in it, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it ran this loop 10 times, and then it went through it and did it 4 times, right? I've got a for loop inside of a for loop, which says run this code 4 times, and so it did do it 4 times. It made a list of 1 through 10 4 times. So that could be kind of simulating a deck of cards, and I've created them in order because it was easy for me to do. Now I know I'm going to have 4 1s, 4 2s, 4 3s, 4 4s, 4 5s, 4 6, etc., etc. But let's say I want to mix those up randomly. I could just do it with code and kind of, attempt to kind of randomly switch values in my code. Or I could use this command called random shuffle. And again, it's the same thing as sort. It just wants the beginning of your list and the end of your list or your vector. So I'm going to write cards.begin. And it says that it's an iterator, const iterator. Don't worry about the const for now. And then the cards.end is the const iterator there. And then I just run that command, and it should internally go inside of my vector and shuffle it all up. Let's see if it does that. So I'm going to go to my watches value here. I'll close up my, I'll keep it open, I guess, and look. It still has all the same values, but everything got mixed up a little bit. Some didn't even get mixed. All the red ones did, but that's good for us. That means there's a little bit of randomness to our shuffle. So it basically just mixed our deck up. If we were going to make a card game or something like that, then this would be a great way to kind of shuffle the deck up after you've got it all sorted out. Okay, so that's another cool algorithm that I think is useful. There's tons in here that are really good. Let's see. You can look for min and max, which is useful. Let's look at one. Let's look at one of these find ones. Okay. Do I want to look at find? There's a fill one where you can fill a whole thing with values. Merge. Heap, which we won't use. Let's look at swap, which could be useful for us. Exchange the value of two objects. Apply function to each range. That's kind of a cool one and very advanced. So if you have a function and you want it, instead of making a for loop and calling that function for every value, you could just write the word for each and it does it internally for you. I'll look at find here because I think this one's a little bit more complicated than you would think. Yeah, you give it the beginning of your list and the end of the list and then the value that you want it to find, and it returns a memory address of that value, which is kind of awkward. Let's look here and see. Yeah, it's a memory address. Weird. P equals find. Okay, so let's say I have my list here. So I'm going to delete all of this stuff for now. Okay, and I'm not even going to see out the list. I'm just going to fill the list with 100,000 values. Okay, and let's say I want to see if it has the value 5 in there or something. So I could write find. I'll write the word lister dot begin. I'll write the word lister dot end. So, and then the last thing it wants is the value I'm looking for. So if I write 5, I want to see what that does. Now, can I see out that? Will it say like true or false? What will it say? Let's see. It won't let me see out it. Okay. And the reason why is because find actually spits out the memory address of where the number 5 is, and cout is doesn't want to spit that out for us. So I wonder if we write the word star in front of it, maybe that'll help. I doubt it. Oh, it did work. There you go. Why does it write 5? Oh, yeah, okay. I'm going to write ampersand inside. It doesn't like doing that. Okay. Let's fix that so it's better for us. So I think what we'll do is just leave it at that for now. This returns an iterator to the point where there is a 5, and it returns the last element if there is no 5. It's kind of awkward. Some of these algorithms are awkward and are meant for more advanced programmers. Let's see out, and we'll put a star beside it. What a star does in C++ is it says if this thing is a memory address or an iterator, um, the star says like go inside that memory address and spit out what's inside of there. So if there's a 5 in this list, it'll spit out the number 5. So let's see. And it does spit out the number 5. If I make the list really short, like 100 big, the chances that there's a 5 in there are really low. And let's see what it prints out. It prints out 0. Let's see if it does it again. 0, yeah, 0. So it prints out 0 if there's nothing in it. And if I make it like 1,000, is there a chance there'll be a 5 in there? It's a lower chance. Let's keep running it and see if I ever get a 5. No. I'll run it 10,000 times. There's a pretty decent chance I'll get a 5 in there. And I do. But it's awkward that I can't find the place the 5 is in. There's ways to do it. There's a command called distance, I think. Distance, and you give it maybe, I can't remember exactly how it works, but that'll tell you the element, but don't worry about that too much. The good algorithms to use are, I think the ones that we use more often than not are the random shuffle, which is good, and I think remove can be kind of useful sometimes. The sorting ones are useful. Merge can be useful if you're doing a lot of data management. Min and max are always useful, but a lot of them are more for advanced coding, especially of like data. And we don't do a lot of data management in this course. We do more like 2D graphics and stuff later on. So, anyways, there you go. We'll talk soon. Bye.